Wow, I've been talking to myself for 15 minutes. I didn't go live in YouTube. Good morning. Let's start this over. Okay. Today, we're gonna learn how to use YouTube streaming. Good morning. Sorry for starting late. I actually started on time, but I forgot to hit the go live button in YouTube, so I've got a recording of the past 15 minutes, which is kind of nice. But I do not have... didn't stream it out to you. So we'll go ahead and start this over. Today's stream... I lost everything. Plus, I usually have a little more buffer in the beginning. Okay. Welcome. It's morning. It's Saturday morning. Hope everyone had a great week and is looking forward to their weekend. And if you're here on your weekend, thank you for being here. If you're not here, or if you're here not on your weekend, also thank you for being here. Just thank you for being here. Today, I'm doing this video or this stream because I had a request in the comments, which I went through last night. Sorry for not getting to some of them earlier. YouTube is not very consistent in whether it emails me or not when I get a new comment. So I thought it was sending me emails. And I got an email that was a spam comment, and I was going to go delete it. It was already gone, probably filtered or something like that. But then I saw a bunch of other comments that it hadn't emailed me about. So I was going through the comments. I saw a request for someone from someone to do a video on how to set up your ZMK config repo and how to use that for building a firmware. And I thought that is a fantastic idea because it is a little fiddly, maybe, I don't know. It is pretty straightforward if you're familiar with it, right? But at first it could be a little daunting. So I'm gonna walk through actually just straight up how to do it, and then start digging into the details of how it works. Both from a, like, you know, here's how to kind of get a little deeper. So, like, very simple, walk through the installing ZMK doc, and we have a firmware, flash it on your keyboard. Done, right? Then go from there and walk through customizing your firmware. So adding a layer, adding a combo, adding, you know, Bluetooth settings, something that's not just a KP behavior, layers, that sort of stuff. Just really simple, basic stuff. Not so much like trying to say, here's how to build your keymap, just more of like, here are some of the ways you use different features and how they work. Mod taps maybe as well because of homerow mods, that sort of thing. But not to try to go through every single feature because that would probably be a longer video, and some of these things I don't even know what they do. It's mod morph? No idea. I'd have to look that up myself. Then dig a little deeper into like how the GitHub Actions side of things works and how building your firmware itself actually works, with the West command and stuff like that, and maybe even go so far as to say, you know, here's how to do this locally with Docker, if you have a Docker install. So that's kind of the idea. And as part of this, like, I'll try to be taking notes because I want to make like a more formal video about this, I think. Because I think it would be better than like a completely unscripted recording of a stream, which is what today is going to be, and what will get posted on the internet. But I think having a more succinct, you know, or maybe even multiple steps, like here's just the basic installation, then here's customizing your keymap, and then here's, you know, the gory details or whatever. Have those be 3 separate videos. I don't know. We'll see. But today it's just going to go through installing and some basic customization, and then I'll walk through like how it actually kind of works, how the sausage is made a little bit. Once that's done, I'm probably going to move on to taking my hodgepodge of various config repos and trying to merge them together. So I have like 5, I want to say. I've got my main one, which has like my corn repo or my corn keymap, and I think I built one for Kyria ages ago. I don't have a nice nano Kyria right now, but you know, that's there. I've got one for the Zaphod. I've got one for the Cornish Zen. I've got one for the Ahokore. Those 4 at the very least. And I kind of want to consolidate them all into one and have it so I can push code to one of those or push a commit to one of those, and the GitHub Actions just builds all of them. Not so much that I need to have that for my own build, firmware build workflow, but like that I have at basically any given time, I have a functioning firmware that I can download off of GitHub Actions. And then also, it'd be nice to try to dry out. So dry being don't repeat yourself. So dry out some of those things, like extract out my defines for the Dvorak, kind of like I was doing yesterday, but that was more for like, I want to have this in upstream ZMK, whereas until that happens, I can still do that locally and dry those out. Maybe go so far as to make macros for my combos so that it automatically offsets the, you know, like the combos assume 34 key layout, but you've got, say, a little padding on outsides or whatever. So I want to try to figure some of that out, or at the very least, just kind of like, instead of having KP DVA, KP DVO, KP DV, it's just like left-hand home row, kind of like I have in my QMK config repo or QMK repos, so that I can just kind of like macro 5 keys in at once. It makes it much easier to build my key maps because I'm not repeating the same thing, and it makes them easier to maintain because if I want to change anything, I change it in one place. So yeah, so that's what I'll do today. That is a much more condensed version of the last 15 minutes of me talking. So yeah, good morning, Linux Fish. Welcome. Yeah, I had the stream going. I was talking. I was doing the spiel, and then I looked, and the button in YouTube said "Go live," which means it's not live yet. So that could have been embarrassing if I had done the whole thing. But at least I had a recording of it, because I am recording today because I want to try to see or edit it down or whatever. I just trying to record just to see. So yeah, let's get to it. So like I said before, the first thing I want to do is just a very basic. Oh, okay. Just a very basic run through of the installing ZMK process. So installing ZMK, this doc, you know, I'll even tell you how to get there. Basically, this tells you how to go from I have nothing to I have a firmware for my keyboard that I can build, download, and flash onto my keyboard, and then actually go ahead and build, flash, and download it to the keyboard. So I am going to flash this onto, or I'm going to build a firmware for my corn. This is my chalk corn, kind of my original chalk keyboard. I think this is the first chalk keyboard I built. It didn't have PCBs before, or it didn't have a case before. It was just bare PCBs. It's nice nano. It's wireless. It's beautiful. I love it. I have a blog post written up about it. But we'll go ahead and build like a stock firmware for it, and then we'll make some customizations to it and flash that and test that out too. And one of the nice things about doing this process on a split is that you see that you have two different firmware files to install. You've got the left hand and the right hand. I don't actually know what happens if you switch them. I think they just reverse. Like it's just like if you wire up the like a split keyboard on QMK backward. Like, yeah, but we're not going to try that. So yeah, so in order to, like, if you've just bought a keyboard or just built a keyboard and you've got, say, nice nanos, say you built this lovely nice nano chalk corn here and you want to build a firmware for it. Well, ZMK is kind of the main firmware people tend to use on nice nanos. So go to zmk.dev and you'll come up with this page. And this is just the main page of the ZMK website. It's got all this stuff here, but you can do get started. I would say you can skip most of this. At least for now. Just go click on the installing ZMK button, which you can also get to by clicking docs up here and then clicking installing installing ZMK. So this first little bit here is telling you what the guide is going to walk you through. So this is not instructions yet. This is, here's what we're going to do. So we'll go through that real quick. What we're going to do in this guide is we're going to create a new GitHub repo. We're going to run a small shell script locally that will ask you what board you're trying to build a firmware for. It'll ask you where you want your GitHub repo to be. And then it'll clone a template repo, run some stuff in there, and then commit the initial version of the firmware. Then it will, if you've set it up correctly, or if you set it up to do so, it'll push that up to your GitHub repo, and then it'll create a keymap file for you that you can customize later and push that up as well and build it. And then it'll set up GitHub Actions and do all that stuff. So, yeah, we're going to just walk through this here. So Prerequisites says you have an active working GitHub account. github.com/kitchen. Whoops. Check. All right. So you have installed and configured the Git version control tool. Clear Git. Okay, we have Git. All right, you have locally configured Git to access your GitHub account. If you're using personal access tokens, be sure it was created with a workflow scope selection option selected. I don't want to get too much into the weeds of how that works, but I would highly recommend using GitHub with SSH. So there are tutorials on GitHub for how to set it up with SSH. The main reason I say that is because you can test whether your SSH to your GitHub account is working by doing SSH git at github.com. And it'll say, hi kitchen, you successfully authenticated, but GitHub does not provide shell access. Boom, perfect. It authenticated you, it logged you in, and now you know that your GitHub SSH access works, which is just really awesome. You can also do Git over HTTP. The problem you have there is that if you have 2FA required, you need to use a personal account token. It's a lot more fiddly, I think, than just using SSH. So I would say, unless you have strong reasons not to, use SSH for GitHub. So before running the setup script, you'll first need to create a new GitHub repo to host the config. Okay, great. So we go here to the github.com and then new repo. We're gonna call this ZMK config/demo. Demo repo for ZMK config tutorial. And the reason I'm calling it ZMK config demo and not just ZMK config is because I already have a ZMK config repo. Don't need to worry about any of this other stuff here. Just click create repository. Boom. Okay, so leave this page up because you'll use it in a minute. So we go back to the zmk.dev tab here. Click create repository. Yeah, do not check any of the other stuff. Okay, so since I'm on a Mac, I'm going to use curl. wget, I have it. No, I don't even have it. But I don't have Windows, so I'm not going to show PowerShell. Sorry. But basically what you do is curl bash. If you're familiar with the term, you're basically taking this shell or this script that's published over here. Whoops. No, I just want to show it. Okay. You're just taking this script and executing it in bash. So there. This is one of my least favorite ways of using software from the internet for a lot of reasons, but this is what we have. Okay, so I pasted that command in there. So it's asking what board we want to use. Now, since we have the corn right here, and also I say board. Board is the wrong term here, because in ZMK and really in Zephyr, which ZMK is built on top of, board is the controller. So board would be the nice Nano itself, right? This is the board. The keyboard itself is the shield. There are some like, well, okay, there are situations like with the Zaphod or with the Cornish Zen where the board and the shield are one, right? There is no real distinction between them because there isn't a separate controller. So in ZMK at least you have oh, I don't see one. Oh no, I guess the Ferris, because that's integrated. Anyways, that's too in the weeds. The keyboard, we'll call it the keyboard rather than the board because that's less confusing for ZMK terminology. Pick a keyboard, and we're going to do number 5 here, the corn, because that's what we're doing. So do 5, do that. And this is actually a nice Nano V1 keyboard. So we're going to pick 2 because that's what nice Nano V2 or V1 there is. Copy in the stock keymap. Yes. GitHub username. Kitchen. GitHub repo name. ZMK config demo. GitHub repo. So this is where leaving this tab open comes in handy, because what you want to do is copy this git at github.com into here, because you don't want to use the HTTPS because various reasons. Also, caveat if you're using SSH. So we look at the thing. Okay, it's MCU board is nice Nano, shield is corn left, corn right. Copy the keymap, yes, and then GitHub repo to push. Git at github.com, kitchen, ZMK, blah. Continue, yes. So what it does is it goes and clones a repo for you. It doesn't say what it is, but it clones a template repo for you, and then does some stuff, creates a couple of files that are needed for the keyboard to work, and then commits that. So if we look here now, we've got the ZMK config repo or config demo directory. Okay, in here, oops, FD. So we've got build.yaml. We've got a config directory with corn.conf, corn.keymap, west.yaml. Also, if we look, there's also a .github directory. I'll have to. So there's GitHub workflows, build.yaml. So we'll get into that later. This is actually how the GitHub Actions stuff works. So, but we don't need to modify it pretty much ever in this process. So if we look here, we've got the config directory. We've got a corn.conf, a corn.keymap, and a west.yaml. So I'm going to go into the config directory here. Oh, and if we do git status, okay, it's origin main. If we do git log, there's initial user config that we've committed to the repo. And by we, that's the script that that you ran. It created that commit for you after it copied all the template and stuff like that. So if we look in here, we've got corn.keymap, and this is your keymap file. This looks a little daunting, especially if you're familiar with QMK repo or QMK keymaps, but ultimately for most people, it should be pretty straightforward. You've got KP tab, KPQ, KPW, etc. This ampersand KP is called a behavior, and the behavior in this case is a key press. You've got a couple of different types of behaviors. We've got MO, which is a momentary layer. We've got BT, which is a Bluetooth behavior, so it's sort of like controlling Bluetooth commands. We've got this trans, which is transparent, and then we've got is there a none in here? None. Okay, well, there's another behavior called none, which just doesn't, it's just an unbound key at that point. But we'll get into that stuff in a little bit. The main thing is here, this is your actual keymap file. This is where you put in your normal, you know, this key is A, B, C, D, whatever. Right? There's a bunch of extra stuff in here that you can see. So this include behaviors, DTSI, keys, BT, all that stuff. This is all part of what is called device tree. It's a way to declaratively define a hardware configuration that then can get passed into code, like a driver code. You don't need to know that much about device tree or really anything to get started with this, but I do highly recommend, like, at some point doing a bit of a deep dive on it to kind of understand what's going on here. And I'll try to either make a video about it or maybe even cover it near the end of the stream, kind of more like what some of the stuff is, because it'll make things a lot clearer, I think. But the main thing is, for this purpose, you can just edit this and not have too much trouble. So that's just the default thing there. Now let's go look over at our repo. So the script also pushed the this repo up to our GitHub account, or up to our GitHub repo. And then I don't know if it created the actions. Oh no, it did. Okay. So it also enabled GitHub Actions on this repo. So if we look here, initial user config. Click on back in the main front page for the repo. Up on the top here, click on Actions, and this shows you all the builds that have run off of this repo. So GitHub Actions is a kind of a continuous integration system. Basically, it'll run a set of commands that you define against your code every time you push a commit to it, or however often, depending on how you configure it. In this case, it pushes it on every push. So every time the top of a branch moves, it'll rebuild on that branch. And in this case, we pushed just a stock config, and it built it. And we can go in here and look at the actual build if we want to. Look at logs. Look at like in here, one of the steps is that actually just dumps out the device tree, the compiled device tree file. So if you really want to get into how this looks, like this is what your keymap compiles to. It's not pretty, and that's why you have behaviors and defines and bindings. But if you really wanted to see what it looks like, this is what it looks like. But the important thing we want here, if we go back a little bit, is just on the main page for the build, down here at the bottom, we got this artifacts, and that is the firmware artifact. Let me see if I have one already. I do, so I need to delete that. Whoops. Okay, so let's downloads. All right. So we just click on this here, and it will download this to your computer. Now, how do I want to show this? Hello, Dakes. So one thing I'm going to figure out here is how to archive old stuff. Sorry, I want to show the actual process of dragging the firmware over, but not like show you all the crap that's in my downloads directory. So I'm fixing this a little bit. Let's get a window capture, binder, boom. Sorry, just adjusting some of the stuff a little bit here. Let's cinch this down a little bit. Whoops, wrong drag. What's up, Daryl? Yeah, this keyboard's alright. I think I might throw it away. Hit with the chainsaw. Okay. Transition. There's Finder. Great. So, let's do this again. We're going to click on this firmware here, and it's going to download that. And in this case, it downloads it to my downloads directory and extracts it. So this is actually a zip file, but macOS helpfully extracts it to a zip file. So now in this directory here, in this download, you've got this left and right. And the reason you need this is because the hardware configuration that goes into the left and the right are different in the device tree, which enables different things. The long and short of it is that the left hand is configured in Bluetooth terms as a central and a peripheral. So it is a peripheral to the computer, and it is a central to the right hand, which is a peripheral to the left hand. So it kind of proxies everything to the computer for the right hand. And that might be getting too much in the weeds, but suffice to say that it needs two different files to do that, because the keyboard itself doesn't know which hand it is. It only knows based on what the firmware is. So it builds a left hand and a right hand firmware. So in this case, we've got the left hand here. Right? It's plugged in via USB to my computer. And what we want to do to program to actually flash this, all you need to do is double tap the reset button here. And if you look in the Finder window over here, we've got this nice nano that popped up. This is just a standard kind of FAT file system interface to the firmware that's running on the actual device. As far as I know, or as far as I understand, this current.uf2 is not quite what's actually running on here, so don't rely on that to be like, hey, I'm comparing what I flashed to what is actually running on there, which I've had to do in the past, or which I've tried to do in the past. That doesn't work. But all you need to do to upgrade the firmware is to just, since this is the left hand, we take corn left nice nano ZMK UF2. We just drag that over to the nice nano. It's gonna copy that file over, and once it's done, the device ejects itself, not cleanly though, which is annoying because macOS complains every time. And you get a little stack of them over a stack of notifications on the side. And then now you've got your new firmware running on the keyboard. So if we go here and I start typing, I've got firmware running on the keyboard. And that is the firmware that we just built and downloaded and installed. So now let's do the right hand. So I'm going to shut this off. You don't need to, but I'm going to. Turn this side on, plug it in, double tap reset. We see the nice nano popped up down here. Go back to our downloads. Horn right nice nano ZMK. Boom. It's copying the firmware. And that is firmware upgraded and should be usable. I don't think I have this paired to my computer. I have it paired to my iPad. But we'll give it a shot here. So in order to get the two halves to talk to each other, you reset them roughly at the same time and they will pair with each other, because one will come up and be like, hey, or the left hand will come up and be like, hey, I'm ready for connections. And the right hand will come up and be like, hey, I'm looking for a friend. Oh, hey, let's talk. And now they're paired. That works 99% of the time, every time. There are some situations where it doesn't quite work, but we're not going to get into that. So now if we go over here, should be able to, well, because it's not connected to the computer, I'm going to plug it in and try. So the right hand works, I can see. The ZMK by default will use the USB connection if it isn't paired with a Bluetooth device at the time. I think this keyboard is paired with my old iPad that I don't have anymore, so there's no Bluetooth connection to pair with, or to do it with. So it just uses USB. But we're gonna set this up over Bluetooth just to make sure that that part works too. So I don't remember off the top of my head what the binding is for that on the stock keymap, but we'll look here. So if we look we've got this, just in the comments here, we've got BT clear, which is on 1, 2, 3, 4, 5, 6. So this is a 6-column map. So BT clear is on this key on the lower layer, and these are numbered in order. So this is layer 0, this is layer 1, layer 2. So we want layer 1. We look in this key map here, and we got MO1 here. So that's momentary 1. So it's going to momentarily switch to 1 and then use that. So we want a BT clear. And what this does is it clears our currently selected Bluetooth profile, which you select with BT 1, 2, 3, 4, etc. It'll clear that Bluetooth profile so that it can be paired again. And I'm going to just quickly run over here and try to find this. Actually, it may, nope. So it actually was paired with this computer. Okay, so here we go. Click pair. Give it a second. Come on, computer. Okay, so I'm gonna reset this again, and I'm gonna actually switch profiles just to make sure. So I'm having some connection issues, and macOS and ZMK have a history of being kind of problematic at times. So, well, maybe I should pull this window up here so y'all can see it. Window capture. Yeah. Okay, there we go. Oh, that was a huge window. So just so you can see what I'm doing, there's my Bluetooth preferences. And you can see I've got a bunch of Bluetooth devices already. Apparently I need to charge my keyboard, or my Magic Keyboard. But here's the corn down here, and this should be... So we're going to select Bluetooth profile 2, and we're going to clear it out. Should just be able to connect to this. Disconnect. Can I forget that device somehow? This is almost entirely my fault because this board has been paired with this computer before, and that means it gets wonky. Okay, well, we're going to use it with USB for now. Works just fine over USB. And it's running the default keymap, so I don't actually know how to type on this thing. This is a... Yeah, I don't know where the space bar is. That's fine. So we've got this QMK or ZMK firmware successfully flashed to the this keyboard. So now let's go ahead and move that off to the side, just so it's not in my way for typing. I'm going to close this, delete it from there. Whoops. Undo. Shit. There. Okay, get rid of the system preferences. So we'll go back over here. And let's say corn.keymap. Let's say we want to change, yeah, let's say we want to change, we swap the space and the return. So we go in here, we just change ret, or space to ret, and ret to space. Now, this white space and stuff doesn't need to line up, and it's really hard to maintain, in my opinion, so I just kind of halfway do it. So if we go here, just as a quick demo, so got space on this thumb, got enter on that thumb. just to kind of prove that we changed it, right? So close that, git diff. So we see that we changed this. We'll do git status so we can see the keymap change. Git add corn.keymap commits. Oops. Git commit, swap space and enter. Close that out. Got that log or that commit in there. Git push, and then we come back over to our repo. We look at actions. Well, wait a second. Maybe. Oh no, wait. Wrong config or wrong repo. Actions. We see that the build is running. Now we can watch this build happen if we want to. Just by clicking on the build and look at the jobs. Let's do corn left. It's doing some setup stuff and it's doing Docker pull, and we wait. And this takes a couple of minutes. There is some to some of the gory details here. There are some things in the GitHub Actions build file that make this subsequent runs much faster. So it caches the images and some of the assets that get built. And we'll go into that much later when we get into how this actually works under the hood. But suffice to say that like subsequent runs won't take as long as the first one did, so long as they're built within a specific time period. And we don't actually need to watch all this happen, but it's kind of interesting to see what's going on. And also gets you some familiarity with what the output looks like, so that if and when you are building this locally on your computer, you can see, you know, oh yeah, this looks normal. It's, you know, you can see in here the number that's like 210, 220 out of 277. Those are kind of the number of build steps. They're not all the same time to execute, so you can't just say that, oh, it's, you know, 1 out of 277 or 50 out of 277 and that's exactly a certain percentage. It's just kind of just based on the number of steps, but they all run pretty quickly, so it takes a couple minutes at most usually to rebuild. So let's go back to actions. Looks like it's done. We've got our firmware. I am going to go over here and I'm going to delete this. Whoops. Go back here. I'm going to drag this to trash. We're going to grab the new firmware. You can see it's over here. And then double tap the reset button on the left hand. Corn left, nice nano. Boom. Alright, so that one's done. Plug in the right hand. Corn right, nice nano. Boom. Alright, now if we go back, plug this back in over here, we can check. So what we did was we swapped the enter and space keys. So spacebar should be this now, and enter or spacebar should be the right hand thumb, and enter should be the left hand thumb. So let's do test space, this space works, and then foo enter. Okay, so we've proven now that we can make changes to the firmware, push them, build them, flash them, and it actually applies to the keyboard. So that's the general gist of how you flash, how you go from nothing to a functioning firmware on ZMK with GitHub Actions, and then make just a very basic, very simple change to the key map. That's it. End of stream. No, I'm just kidding. So now what we should do is whoops. Look at the key map. So let's say we want to add another layer. No, let's not quite go that far. Let's say we want to... Okay, let's say we want to put on our left central thumb, we want to put backspace. So we want a mod or a layer tap in QMK terminology, so that when you tap on it, it's one key, and when you hold it, it's another. In ZMK, what you're looking for is a behavior. So you've got this MO, which is a behavior. KP is a behavior. BT is a behavior. So you click over into the ZMK docs, behaviors, here we go. Key press, that's your KP. And then it even says here, to make it easier to decode hit keyboard numeric values, most key maps use that. The ZMK keys.h just says what R, S, T, it defines all that stuff there, which themselves are macros that include other things, like it's a thing. But key press, reference KP, and then you say, you know, which ID you want to use, which key press, right? So that's your basic key press behavior. Layers, we've got MO for momentary layer, layer tap, which is an LT behavior. Two layer, which is two. So what that does is it basically switches your base layer, your default layer. Toggle, you know, it turns a layer on until it's turned off. I'm not really sure what the difference between toggle and two is. I don't know. I don't use them, so not sure, but we'll start with just layer tap here. So the layer tap takes two parameters. You say which layer you want to switch to, and then what the tap configuration should be. So we want layer tap to go to layer 1. So what we want to do is change this to LT, layer 1, and then BSPC is backspace. And I don't know that off the top of my head. I saw it was over here. I was like, I know backspace is on this key map, so I just pulled it from over here. But if you need to look it up, key press codes, this has all the things. So if we look for BSPC, we've got backspace here. So let's also change on the right hand. Maybe we want layer tap 2 and then make this escape. So again, I see escape right here, but it's also right here. Oh, and you can actually click on it and copy it. All of these things over here are like which operating systems that's supported in. I'm not sure the exact details. We got Windows, Linux, Android, Mac, iOS. There's like star supported, not tested yet, Linux, not supported, that sort of thing. There's also some like in here differentiation between consumer controls and application controls or something. I don't know. There's all sorts of fun stuff in here that I don't use. But if you ever want to, it's just codes. It's a top level docs thing. It looks like codes, full list. So there you go. Oops. I need the escape key. So let's change that and we'll write that out. Git status. Git add corn.keymap. And actually I want to do one thing here. No. I want to Okay. It's like I hear something in the background. I don't know what it is. And it's my neighbors are selling their unit, so they're showing it. So I'm gonna accidentally put in a syntax error in the tree here. So we're gonna do 2 escapes by accident. So what this is gonna do is it's gonna allow us to look at debugging this, or at least like how does that even work. So git add corn.keymap, git status, git diff cached. So we see that we added, you know, backspace and escape on our thumb keys, on our layer keys. Git commit. Oops. Add backspace and escape as layer taps on thumbs. Okay, and git push. So now we go over here to the GitHub Actions. And we wait for this to go. And as you can see, the first one took 3 minutes, 55 seconds. The second one took 2 minutes and 2 seconds. So we should expect roughly a full rebuild will take about 2 minutes. Okay, now my other neighbor is vacuuming. If you're thinking, wow, you have really loud neighbors, or wow, your walls are really thin. I'm in the basement of my condo, and the walls are like, basically the basement is just a long tube, and the walls that separate the units are literally like 2x4 stud wall. Like, they're not meant for sound insulation and stuff like that. They're probably not. They probably should be like firewalls and stuff like that to be fully up to code. But this place was built 100 years ago, so this isn't. It's not normally that like easy to hear your neighbors upstairs. It is down here just because the walls are basically paper, but it's a basement. I just happen to use it as a workspace. Okay, so this should be almost done failing. Oh, and we can see, yep, it failed. Now, why did it fail? So you're gonna see a lot of really nasty looking warnings and errors and stuff like that. And this is kind of a byproduct of the fact that ZMK uses device tree very heavily. So you see this error: DTNS keymap default layer P bindings IDX PHP blah 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 blah. You're just like, what in the hell does that mean? Device tree compiles to like 1,000,000 macros. Or 1,000,000 C macros. It's kind of crazy, and it works really nicely. But it compiles to 1,000,000 macros. So some of the errors are just like, I don't even know. But what we can do here, scroll all the way to the bottom of all this crap, and we're gonna see well, maybe not. Hang on. Let's see. There should be failed keymap object.c. Okay, well, that wasn't the error I was hoping for. Let me change this. So the error I was hoping for is a device tree syntax error, which is like the most common error you're gonna get. But instead I got that, which is just hilariously, I don't know. And like I said, this is a mostly a function of the fact that ZMK uses device tree heavily, that these errors are not very good, not very human consumable, I would say. So we're gonna just get rid of the semicolon here. That'll throw a syntax error. Git add corn.keymap git commit editor. Whoops. And we'll do oops, added an extra escape. Git push. I was also really confused why it was taking so long to build, because it should have failed much more quickly. But see, the fun thing is the right hand worked fine. And that's because of the way ZMK under the hood like split that array up of keys. It's yeah. I don't really know. But this should fail pretty quickly on both of them because it's a device tree. The compiled DTS file will be syntactically invalid. And that is probably the most common error you'll run into. Okay, so it failed on the West build step. The way this will manifest is, one, you'll probably get an email from GitHub about it saying your workflow failed. If you have that enabled, and I think I do. I'm not going to, well, I'll look in my email, but I'm not going to show you because that is my personal email. And yes, I got a failure there, email. So if we look here, we can see, okay, 2 jobs failed, 2 errors. So let's pick the left one, and it automatically expands the failed build. So if we look in this error, what we see here, unable to parse input tree is what we're looking for. And that's because error nice nano dts.pre.temp 779.1718 syntax error. Now, what's this nice nano dts.pre.temp? Well, that's the like fully consolidated, compiled device tree file. So device tree is very similar to CSS in the fact that like it defines a structure of things, and then you can like add more, and it overrides certain things. So basically, it takes all these device tree files that it has and just kind of concatenates them into this big file, and then device tree parses it and layers things on top of it as it goes. So one of the steps that ZMK does, or that Zephyr rather does, is it builds this temp file that is effectively all of the config, all of the device tree concatenated. Now, because you can't see this file directly because it's in Git, or because it's running in GitHub Actions, ZMK, the GitHub Actions build, has a very, very nice, very handy step that just cats the file out to the output. So if you look here at this corn left nice nano DTS file, that is this nice nano dts.pre.temp concatenated, right? If it exists, then concatenate it. So if we look here, we want 779.17 to 18. So what that is saying is that's line 779, and it's column 17 through 18. Because this is the very end, or it's not the very end. Oftentimes this is the very end of the device tree file because you miss a semicolon, like at the end or something like that. But we just look in here, and all these lines are numbered on the left-hand side here. But they're numbered inside it as well because they're not one-to-one necessarily. So what you want is the second column numbers, which is actually the number of the file. So if we look at cat-n, -n puts the line number, or enumerates the lines, I should say, because you can pipe stuff into cat and it'll just spit out numbers. So if we look for 779, was it 779? Yes, 779. So you're like, well, what's going on here? There's a thing. Well, but you look above it and there's a missing semicolon right here. And again, this is one of those things that it's like, you're looking at this, you're like, what the hell is all this? Just try to like look at, take a step back a little bit and look at this, and you'll see that this is, there's a comma here, or there's a missing semicolon here. There's a, in the ZMK Discord, there's a macro for like how to debug this that's much more succinct and much better than what I just told you. And in the like future, this is a video that exists, I'll probably put a link or a little thing up here or whatever, such that like it takes you directly to that page, because it's very handy. But this is a very common thing. I want to like trigger this error during this process and be like, oops, and we screwed it up. So let's go look at the debugging documentation, because this is one of the things that as you're building your ZMK key map, you will run into this and you will get frustrated by it, and knowing how to find what it's complaining about is crucial. So I want to like make sure I trigger that. But since I know what it was, or since I like did it very obviously, like, here, let me put this in here, I wanted to try to like make it a little more organic, like I accidentally put it in there, and I'll figure out a way to do that for the proper video form of this. But I forgot, and then I was like, wait a minute, I should do that. So I went back into the file. Yeah. Anyways, so we do git add corn.keymap. Why is that there? Okay. Commit. Enter. And when I do this for the video, I will just export edit. You know what? Actually, export editor equals. Yeah. The reason I want to do this with Vim is because I think a lot more people are familiar with Vim than Emacs. Especially because Emacs, when it looks like this, and when I'm doing like, let me pull up this thing and magic, like people are gonna be like, what the hell are you doing? Whereas this is much more command line friendly. So probably do that. But git commit. And then, oops, accidentally deleted a semicolon. And git push, and then that should build. So let's look at the next thing we want to do. So we got layer taps, we've got Bluetooth functionality. Yeah, let's look at the key map itself again. Whoops. So we've got key presses, we've got layer taps, we've got Bluetooth behaviors, we've got transparent. So transparent, what that does is it makes it so whatever key is at the next layer down. So if you think about the layers as a big stack of layers, transparent just makes it so, okay, the next layer down is what this key is. And if you have a chain of transparents all the way down to something that you can chain it all the way down to, say, the default layer. I'm not sure what happens if you have transparent on the default layer. I think it might just be none. I think I have none on everything instead of transparents, but whatever. But it's a nice way to say, like, I want to overwrite a couple of these keys, but any other key, like, it doesn't really matter. It should just be transparent.
And the names of the layers, this is an arbitrary label. It doesn't have to be raise layer, lower layer. It could be called foo. Like not even foo layer, just foo. Foo, right? And then you need your semicolon. And then just like bindings equals whatever. But we'll get into that. We'll get into adding a layer in a second. Excuse me. In fact, why don't we just do that now? Might as well. So back to actions. This is still running, so we'll go over here. So let's say we want to add a navigation layer. We'll just call it nav layer. Okay. So bindings. So each layer has this bindings array that you want to give it. And oops, so we do that and that. Come on. Right, so that's kind of the skeleton of a new layer. Like I said, this nav layer doesn't have to be anything. It could just be nav. It could be van if you want to do it backward. It could be whatever. Doesn't matter. It just has to be a legal device tree thing. So underscores, I don't know. Whatever you want to do, pretty much call it whatever you want, and device tree will yell at you if it's wrong. ZMK doesn't care. ZMK only cares about the order of them for numbering, because you use momentary and to and that sort of thing. you use those, you reference those numerically, not by any kind of name. So we need 42 keys. So let's just go ahead and do let's see, tab. So we'll do none. Whoops. Okay. Space there. Two, three, four, five. Okay. I was trying to do, I know how to, or I know there's a way to like, just so I can quickly do, I'm gonna type it all out. Screw it. So that's 6, 7. 8. 9, 10, 11, 12. Shift V. Come on. Why are none of my things working? Okay, Shift V. There. So there's 3 layers of that, and then there's 6 thumb keys. Okay, so one thing you might run into is if you actually try to build this right now, it won't work. Because I think none maps to something that device tree kind of collapses to nothing, and then it won't work. Like, device tree doesn't like having an empty layer like this. That may have changed, because when I first was doing this is exactly what I did. I was like, I'm just going to set up another layer that's all nuns and then see if it works, and great. And then I got some really bizarre error from device tree. The way you can avoid that is just to be like KPA. Boom. There you go. Now it will compile and work. So we defined a layer that is just
nothing, but in the upper left corner is A. But that's not a very useful layer. So we're going to do what I do, and I have an inverted T on my right hand. So on the, let's see, UIOJKL, OJKL, if you're thinking of QWERTY, I had to think about it because I used Dvorak. So in Dvorak, this would be CHTN. But like middle finger top is up, and then I've got left, down, and right on the home row. And I hold my left thumb or my right thumb to activate that layer, and I just use it like that. And this is part of my actual. I use this keymap, or I use that myself. Let's see, word done. Okay, so that is the 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So this is KP up, I think. Let's go back to codes, up. Yeah, there's up arrow, down arrow, left arrow, right arrow. Okay. But we can just do that. So let's see. Let's go to the beginning of this line here. 1, 2, 3, 4, 5, 6, 7. So this would be KP left. KP down. KP right. Okay. And then what I want to do, back up here, we're going to take space. That is not what I want to do. Undo that. Space. Okay, so we're going to change this into a layer tap 3 space. Okay, so that adds another layer, which because we've got layer 1, or layer 0, 1, 2, 3. We reference it by number. We've got our navigation layer there, right? So let's go ahead and close this out. Git add corn.keymap. Git commit. And then add a nav layer. Okay, and then push that. Now, one thing you might be thinking, maybe, is, oh, if I'm pushing this to GitHub and they're building it, are there any limits on that? And the answer to that is no. For normal users, you will not run into limits on GitHub Actions. No matter how much you push. It's just not... You'd have a difficult time running into that. But there are limits. So if you run into that, there you go. But if you're in danger of running into those limits, you will probably know and will have either worked around it or just you pay for it or something like that. But suffice to say, for normal people, especially doing ZMK stuff, that you're not going to run into limits. You're not going to get charged for this. This is a free thing that GitHub offers, and or for a limited amount of compute time and stuff like that. And like big companies that have thousands of developers use this, and they pay a lot of money for it. But you don't have to. I have a pro account, I think. I pay for GitHub. I used to, anyways. So I may have other things, but yeah, you're not going to run into issues with this. But good thinking. So the next thing let's do is we've got the nav layer. I don't have any ZMK boards with lighting, so I can't do that. let's do a mod tap for fun. So let's implement home row mods. Why not? So if you click on mod tap, there's even in here home row mods. Now the cool thing about the way ZMK does home row mods is if you look in here. Oh wait, it isn't in this. Well, anyways, if you look in here, you've got mod tap. So the key code should be sent when activating as a modifier, left shift. So mod tap, left shift A, right? But with ZMK, you can define behaviors in your ZMK keymap file because behaviors are just device tree things, right? So you can define your own behaviors. And the nice thing about that is that you can set up very, very easily per key settings for layer tap, for mod tap. So for your home row mods, maybe your home row mods need to have different tapping term or whatever for whatever other settings home row mods need to make them work better for you. And you define that in your key map, and then you can use that. So you can do all sorts of stuff, and it makes it kind of a shorthand thing. So instead of like writing a function that says if this key, if that key, whatever, I don't remember how you have to do it in QMK, you just declare a behavior and then use that behavior in your key map. And I'll show you how to do that in a second. First off, we're just going to do mod tap left shift A for grins, right? We'll do it just as the thing here shows. So KPA. So let's change that to mod tap left shift A. There you go. Now if I tap A, it's A. If I hold A, it is a left shift. Obviously it's not active on the board because we haven't committed, pushed, all that, flashed, but suffice to say, that's how you do it. There is, let's say under miscellaneous? No. ZMK home row mods. Hold tap behavior. Okay, so under behaviors, if you click on hold tap, so there's mod tap and then layers, but there's hold tap behavior here. And I think mod tap and layer tap are just like implementations of hold tap, like in the actual device tree stuff. So this is kind of the hold tap is the basis for other behaviors such as layer tap and mod tap. So you can basically define your own, and it talks about that in here for home row mods. So an example, this example configures a hold tap that works well for home row mods. So in your device tree, so you can put this anywhere in your device tree file and it will work. Or rather anywhere in your keymap file. And I say anywhere, I mean like if you think about this as kind of like if you're familiar with HTML, this is your root tag. This is your kind of like your HTML block. If you just think of these as code blocks, you can copy paste these into here. And this is actually specifying the root of the tree. I'm not going to go too deep into that, but you can take this behaviors, or you can copy paste this whole block in if you want to. Of course, this is specifying your full key map here, so you don't want to do that. Or you can copy just this part and close it, or just take this behaviors thing, copy it into your key map file. Whoops. Like that. And the indentation is bad, or it doesn't match up. That doesn't matter. I'm not going to fix it. If in my normal editor, it would fix it for me, but I'm not going to bother. So basically, this is saying behaviors HM. So in device tree, this is an alias. This is a label rather, and that allows you to this HM colon. This is a label that allows you to reference it later. So if you look at KP here, This is a label that is defined in ZMK device tree somewhere, right? And if you look at the actual device tree file from your build, you will find that KP colon somewhere in that file. Or there's a way to do it with a special alias thing, whatever. But let's just ignore that for the moment. So home row mods, this is again just an arbitrary thing. It can be whatever. But the compatible ZMK behavior hold tap, this is the important bit because this is kind of specifying the driver for this stuff. Mod tap will work in normal key presses as well. Mod tap AB. I don't know. I would suspect that it will spam it in the sense that your operating system will see that as you're pressing. You'll see the operating system will get a a key press A event. Because remember that in the way keyboards work is you don't just get a I pressed H. You get a key down H event and a key up H event. And your operating system can then interpret that however it wants to. Now, your keyboard firmware might change that because you can have built-in key repeat. You can have like all sorts of weird stuff that can happen. Or maybe you've got like one that I actually use a fair amount is I have a layer tap, and then I have a browser and tab navigation. So if you see me like using my keyboard to navigate between tabs a lot, or navigate within a tab, that's just me hitting command curly brace, command left curly brace, command right curly brace. But command curly brace isn't a thing. Command shift square bracket is a thing. So when I press that, it as actually pressing 3 or doing a key T down event on 3 different keys, and then when I let go, it's a key up event on those. But then if I do like hold the option key and then do that, like notice it doesn't do anything, but it has option is still held right now because I'm holding the key down, right? And the option is a mod tap. It's or not a mod tap. It's a home row mod, but it's a what do they call it? Hold tap behavior. So I would say that it depends on what your operating system will do. Actually, you know what? Screw it. Let's just test it. Funsies. We'll change this to mod tap Z, and if we hold it, it's L, right? Although that's going to get really confusing because it's not actually L. Let's change it to M, because that's not going to be Z either. Anyways, so I use Dvorak. So when I hit the Z key, that actually has a semicolon. So this is going to get a little confusing, but just work with me here. But what I suspect will happen is you'll get a key down event for M, and then when you let go, it'll get a key up. So whatever your operating system does with that in the meantime, which will probably be like repeat this key, it'll do that. Mac OS is a little bit different because it treats certain held keys as I want to choose the like alternate character for it. So like if I want an accented O, if I'm typing Spanish or something, if I hold O, maybe O is a bad one. A? Yeah, if I hold A, you can see I can now press 2, whoops, A2, and that gives me an accented A, right? So instead of macOS repeating the A key for me, it puts A and then asks me if I want a accented A or not. Now, if I do that in my terminal, I don't know what'll happen because it behaves a little bit differently in my terminal, right? So that's what I suspect will happen. And we'll give it a try in a minute. What's weird is I don't know what semicolon held gives you. And I can't actually do it because Yeah, I think semicolon will repeat, but that's fine because what about M? I don't know, because see, I have a hold tap on M too. I don't know. It's hard for me to try this because, wait, it's not. Because this board is actually using, let's see, M. Yeah, so if I just hold M, it doesn't do anything. Yeah, because this board, the white switched or the white capped board, doesn't have home row mods on the bottom row at all. Whereas this does, so I can't hold things because if I hold them, it doesn't send M a bunch of times, or it doesn't send it, like, yeah, it's a hold tap. Does that answer your question? I am pretty sure it's just going to do it. It's going to repeat it, or whatever the hold behavior is for your operating system. Okay, so we added our nav layer. We've got our firmware if we want to. So let's look here. Advanced configuration, tapping term MS, quick tap MS, retro tap. I don't know exactly what all these things do because the only non-default tapping term or layer or mod tap, or not mod tap, hold tap behavior stuff I have is this Humro mods thing, and that's all I use, and I literally just copied it from here. But so we copied this into our device tree. Now we can reference this down here. So if we want to mod tap, so let's say we want to, so instead of mod tap left shift A, or, you know, mod tap, so let's do shift control, let's do SCAG. So shift control alt GUI. We go here, we do HM instead of MT because we've defined our HM here. So HM LCTRL. Is it CTRL? Yes. Then HM L alt. And then HM L GUI. I think that'll do it. Yeah, there's L GUI, R alt. Okay. Okay, git add corn.keymap. Git commit humro mods scag on left hand. I'm not going to do the right hand because this is just a demo. Okay, so now another big one that people like is combos. So we're going to do combos, and then I'm going to call it on that front. Combos in ZMK are a little different from what you've probably done with QMK. So in QMK, you say, like, I want to, when I press A and S, or let's do one that I actually use. I want, so this is YUIO. So UIO on QWERTY, I want UIO to be enter. So I hit all three UIO at the same time and it sends the enter key. Because this is my actual enter key on my keyboard. In ZMK, you have to specify the key position because unlike QMK, and this may have changed, ZMK does its combos early. They call it early combos. And I know QMK has some early combo stuff now, and I think it's default. It's just the way it's defined. By the time early combos happens on ZMK, it doesn't know what the keys that might be pressed are. It only knows which key positions have been pressed. Whereas QMK, either it knows it internally somehow, or it like maps it internally at compile time to the rows. I don't really know. But ZMK's implementation is that you say, I want, in this particular case, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are the keys we want. So 7, 8, 9 is the combo. So when we hit keys 7, 8, and 9 together, we want to send enter. So if we look over here, behaviors. So combos are not a behavior in ZMK. Combos are a driver. I don't know if I'm using that right, but they're just another completely different section of your keymap. So if you look here, they're configured in your keymap file, but are separate from the keymap node. So they are similar to the behaviors node in that they're separate from the keymap node. So in device tree terminology, this is a behaviors node, and this is a keymap node. They're different nodes in the tree. It's like you got to think of this as just a big tree with stuff plugged into it. I'm not doing a great job explaining that, just because I have a hard time explaining things to people that I can kind of like visualize, but it's like, how do I convey it? Anyways, so you've got this combos node, right? Combos, so we'll paste that in here. Actually, let's just do this by hand because that pasted all crappy combos. And this is, like I said, one of those times where you're gonna run into issues with syntax errors in your device tree file because you forgot a semicolon. So you'll need to know when you're adding the combos node. You know, it's possible. Look at all these semicolons in here. You've got there's 1, 2, 3, 4, 5, 6 that you're going to have to add. Your odds are good you're going to forget one of those. If you've ever written C or Perl or anything like that, forgotten semicolons are just a fact of life. And I think this is like device trees errors for that are almost the worst ones I've ever seen, but at least like knowing where to find that is important. So the compatible thing, that is a device tree binding thing. So it says what driver to use. So compatible equals ZMK combos. So just know that you need to do that. Put that there. Then combo escape. This is, again, arbitrary. It can be any name, whatever. It just ends up as an array of like children. But we're going to do combo enter in this case. Combo enter. And I think I know why I have trouble with semicolon is because my hold tap term needs to be modified a little bit for my left pinky. I think it lingers a little too long. So I might actually do that on stream today. We'll see. Wow, almost 2 hours in already. Wow. Okay, so timeout ms equals 50. Key positions equals. And this is where those numbers come in because you need to know which numbers they are. And they're the same numbers that correspond to the bindings down here numbers. So it's, you know, on most keyboards this is going to be top to bottom, left to right, or left to right, top to bottom rather. So it's starting from 0. So in this case we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we do 7, 8, 9. Okay, and then bindings equals, and then kp enter, like that. Okay, so that should do it for adding enter as a combo. If you want to do more combos, you just do, you know, let's say we want to combo escape.
whoops. Timeout ms equals. This is a little verbose, and I think it's in large part because it's kind of a feature that was implemented early on that hasn't been super revisited for usability, because it just works. Like once you figure this out, it just works. And it's not so wordy that you're like, oh my god, I don't want to deal with this. So it's not terrible. It's really the only additional stuff is the timeout ms thing, which might actually have a default or a good way to set a default. I don't know. But whatever, we'll just go with this. Key positions equals, and then let's do, I've been actually wanting to try this combo escape on my, so I've got enter on the right hand top three. Let's do escape on the left hand top three. So we got 0, 1, 2, 3, 4. So 2, 3, 4, right? And then binding equals kp escape, like that. And then there we go. That should do it. Okay, git add corn.keymap. Actually, let's do git diff. What else do we change? Nope. All right. Let's just look to see if we have any recent builds. Okay, so the Homer mod stuff worked. All right, and then after this, we will flash this and put it onto here. And then I'll go through how this is actually working under the hood. Like the build part anyways. The device tree stuff is not really sure a great way to like walk people through that. Because I don't know it. I don't understand it well enough myself to be able to, like, I can kind of tell you how I see it, but I don't know if that's accurate enough that I would want to convey that, because, or for fear of like leading you down the wrong path. Like I could talk about LDAP and how it's a tree and how that works, and we could go all day about that. How there's children and stuff like that. I could talk about the DOM and how that works. And the device tree is very much like a DOM, I want to say, but I don't know. I don't want to tell people bad information. Like, this is how I see it. It makes sense in my brain if I think about it this way, but that might be the totally wrong way to think about it in the grand scheme of things, and it just works in this tiny little subset. You know, I don't want to do that. Oh, and we've got a build failure. This was unintentional. I did not think that I didn't intentionally put a thing in here, but let's see, CMake error. Yeah. So error bindings is marked as required in properties in combos.yaml. So, but does not appear in nodes combos combo enter. So what that's saying is this ZMK combos.yaml, this is what's called the device tree binding. So ignore this binding, this bindings, because that is the parameter that it's talking about that's defined or declared in the ZMK combos.yaml. This binding is the thing that maps a device tree compatible to the code that actually interacts with that. That's probably really confusing, but just suffice to say that, like, if you really wanted to, you can look in this ZMK app DTS bindings combo.yaml, and let's actually go look at it. ZMK firmware ZMK. So ZMK combos.yaml. So this is kind of the like schema
or spec or whatever you want to call it for this chunk of device tree configuration, device tree code, but it's configuration. And it also specifies like compatible ZMK combos. So when you write your driver, you say, "Hi, I'm the ZMK combos driver," and device tree says, "Okay, here's your config." There you go. It's way more complicated than that, but that's kind of how it works. But this is kind of your spec, right? So it's saying child binding, it needs a combo, right? But in the, or rather, so child binding, this is basically like any children within this block, in this node, are declared, are bound this way. So we've got properties. So each of these blocks needs this property. It needs a bindings property, which is a type p handle array, and that's a device tree thing. And it's required true. Key positions required true. Timeout ms type int default equals 50. So we could actually just leave that timeout ms off because the default is the same as what's declared. Slow release type boolean layers. I don't even know what that is. Or no, layers. So that's probably, it's only active if you're holding a certain layer key, maybe. I don't know. I haven't looked at that before. But if you ever want to see like what things are supported, you can look at like the keymap. Okay, here's the label bindings, sensor bindings, whatever, right? But we'll go back to ZMK combos. So what this error message here is saying is that bindings is marked as required in properties. So if we look at properties, bindings required true. That's what it's saying, right? And like I said, the binding part is a little, because it's an overloaded word in this case. Because if you look in here, it says in ZMK config bindings. I don't know if I'm explaining this well enough, but it just, yeah. But does not appear in the node / combos combo enter. So if you think of device tree as a kind of almost like a file system, although apparently people don't know how file systems work anymore either, or like directories and stuff. Anyways, so you've got / and then combos. So if we look at our device tree, if we look at our keymap here, we've got /, that's the root, and then we've got the combos, and then combo enter is the one it's complaining about. So combo enter, and it's saying bindings is marked as required, but it's not there, and that's because I called it binding and not bindings. And if we look, combo escape has the same problem. Okay, so there you go. We've actually debugged a real thing. I legitimately didn't have the foresight to put that in there as a failure. But that's an example of one of the errors that you might come up with in your device tree configuration and how to debug it, or how to, interpret the error message it gives you. So let's fix that. Git commit add corn.keymap git diff cached. So we just see that we change binding to bindings, and git add or commit binding git push. Now this should build, and we should have a functioning keymap. That was a bit of a roller coaster blast through here, but I hope that like some of that made sense. The way this has started to make a lot more sense to me is because of working on the circ trackpad. Like literally I have to figure out how do I declare the trackpad in device tree and then pass that to a driver or load it up as a device in some code. I haven't gotten to how to load it up as a device in code yet, which is the thing I've been struggling with. But I at least think I have it declared properly in device tree as a SPI device. So yeah, and as a result, like, you know, I've had to learn about device tree bindings and what is device tree even, and how does this work, and yeah, it's been a lot of fun. If you want to dig into that sort of stuff, I highly recommend digging around in Zephyr, because Zephyr is really awesome software. Makes some complex things much more complex, but makes them easier at the same time. Like device tree is kind of, yeah. Oh, and it broke again. Why? Hello, Archie. Archie? Okay, so let's see. Key positions is marked as required in properties in the ZMK combos. So I screwed it up again. Oh, key positions. Okay. Now you might be thinking to yourself, wow, this is a really slow feedback loop. And you'd be correct. Which is why I like to build locally when I can, because that is maybe not faster, but I can pull the pieces apart more easily. And the reason it's not faster, at least in my case, is because I'm running a x86 image on an M1 Mac. Docker container, rather. And there isn't an ARM compatible container yet, so I can't really change that. One of these days I'll add that to my list of like stuff I want to do with ZMK, is make it so ZMK has an ARM image for building, because that's just like a ZMK Docker repo. Yeah, like basically modify this and it'll spit out the stuff, but the Docker file in here has like x86 hard coded, so I'd need to figure out how to change that somehow. Just something I haven't done, and Pete hasn't done. There probably just hasn't been enough demand for it, that it has gotten done, or that has gotten done by, you know, Pete or somebody else. Anyways, let's see. So now we have a built firmware. So let's go ahead and download this, but let's go back to here, drag this to trash so we get rid of it, download the new firmware. Boom. Whoops, I already have that open. So firmware, double tap reset. Okay, so that one flashed. Plug in the right hand, double tap reset. Nice nano, copy that over, boom. Plug it back in the USB, and now, let's see. So let's do vim horn.keymap. Aha, so if we hold A here, now that's shift. Whoops. Oh, that's control. Actually, you know what? Let's do this. Let's go to GUI. Let's go to QMK toolbox. Or no, QMK. Okay, so my enter combo works because I'm actually using it. So let's go. I know this is a stream about ZMK, but you know what? This test keyboard input thing is really friggin' handy. So if we hold A, we get left shift. So we got shift, control, alt, GUI. Maybe. I know I just used it. Okay, well, so maybe GUI doesn't pass through. So we got A, S, D, F, G, H, J. So now we hit our 3 escape. So there's escape, enter. Okay, so we've got all of our layer taps and combos. Let's check our nav layer, up, down, left, right. Okay, for some reason those aren't working. Oh, I see, it's offset. This is off by 1. So when you're doing your stuff, you know, you might run into off by 1 errors. So the whole thing is off by 1 column. That's fine. Let's see what else. Yeah, I don't know. I think that's pretty much it there. We've got a bunch of different features. We've got layer taps, we've got combos, we've got mod taps, we've got home row mods that are distinct from mod taps, even though it's all the same thing underneath. So actually, we can go look at that real quick. Because this map is different enough from my normal map, I'm gonna keep using my whoops. Foo vimcorn.keymap. So see this compatible equals ZMK behavior hold tap. So that's another one of those things where if we go DTS bindings, ZMK behavior hold tap. And so you can see the properties that are required, what properties are available, that sort of thing. That's very much getting into the weeds of like ZMK, but like if you want to see like, well, what's even available, and the docs aren't good enough, or you're like me and you'd rather dig in the code, this is where the code lives. Right, the DTS bindings is very like all this stuff here. Keymap sensors, I don't know. There's also so one thing someone's probably going to ask about is, especially because I think the comment I was responding to, or this is a response to, was talking about Akira, is how do you do rotary encoders? And I haven't done rotary encoders in ZMK. I have like 3 keyboards that have rotary encoders, and they all start with Kyria. Or they're like a macro pad that came with one or something like that. I don't use them, so I don't really know. Like my Kyrias have 2 rotary encoders. The right one is a volume control and mute button, and the left one doesn't do anything. It's literally not mapped at all. So I don't know for sure, but I know that it supports it. And the way it does it is similar to QMK. The push button of a rotary encoder is just a button in the matrix, right? Because that's how it's wired, and that's how the code, that's how ZMK code thinks about it. But the turn is a driver, and like it's a driver for the rotary encoder, and that's because it gets events on 2 different pins that are direct wire. You could probably, I'm just thinking if you could probably like have 2 different key maps, 2 different thing, I don't know. Anyways, I was thinking I don't know if you can actually mix and match direct wire and matrixed style pins in a key map, or in a ZMK setup. But anyways, Rotary encoders, so enabling EC11 coders, config EC11, trigger global thread. So this sensor bindings thing is, which sensor and counterclockwise and clockwise key. I don't know exactly how to use those or what the implementation is like, but there you go. How can I add a combo for second row? It will be the next number after row 1. So in this case, in the case of the corn, and this applies for 5-column as well as 6-column corn, because in 5-column corn, it's still mapped as a 6-column corn. You just don't have the outer keys. So you still have to declare those as none or something like that. But anyways, let's just go, since I have 6-column corns in front of me, a 6-column corn, you've got 0 through 11, and then 12 through 23, and then 24 through 35 are your numbers for your alphas, basically. So, like I said, the numbers that you use for the combos map to the numbers. Like if you look at your key bindings, if you look at your layers, so let's say default layer. So it's the same order that this array is in, are your numbers for your keys that you're trying to add to the combo. So you've got KP tab here is key 0, and then this is key whatever. It's just, you can count it. I count it on the board, however you want to do it. Again, I think that this is a feature that could probably use a little more love. I don't know exactly how that would work. It'd probably be some preprocessor thing that says like, oh, it's going to look up in the default key map or something. I don't know. Whatever. Your mileage may vary, blah, 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 blah. For now, you use numbers. It's not perfect, but it works. I mean, it does exactly what it needs to do. It's just not the easiest user interface. Because intuitively you think, oh, well, when I hold FGC, I want enter to happen. I say FGC, UIOP, or no, YUIO. So when I hold UIO, or when I tap UIO, I want enter to happen, right? But you have to map that to the actual numbers. And that also makes this harder to port, because those numbers are different between keyboards, unless they're the same layout. So there is in my attempts to dedupe my own firmwares or my own key maps, I want to write I want to make a key map generator that is somehow layout aware. So I can say like, here's my 34 key standard key map. Make it fit in this box. And this box being, it's a 34 key map, or it's a 36 key, or it's a Kyria with 50 keys, or it's a Sulful or Soffle with 100 keys. I don't know, but I just want my 34 key map on there, and it adds padding to the outsides, padding to the insides if need be for like things like the pinky, which have inner columns, that sort of thing. Like, just map it in there, and I want to have it so it also so I can do key positions 7, 8, 9, and that 7, 8, 9 is referencing the 34 key idealized 34 key version of the layout, and it increments or changes those numbers based on how much padding it needs to add. But then it would also need to be like, well, 7, 8, 9 is top row, so I only add, this side, and maybe it's like 7, 8, 9 is also right hand, so I'd have to figure out things. But that's something that a computer can do very easily. You just have to write the macro for it, and that's farther down the road, but it is something I'd like to do, because I want to just be able to say like, for the default layer bindings, just say like kitchen's layout 34 and boom, right? Or kitchen's layout and it's got this much left column, this much right column, or this many outer columns, right? To specify the number of columns around, or the number of keys around the 34 key map, kind of like plugging in offsets. And then be able to just kind of like spit that out there. And it adds padding, right? It adds nuns or transes where they need to be added. Of course, that then makes it so I can't put like on my Cornelius, I've got my 34 key mapped, but I've got a couple of the extra keys that I have on there mapped to certain things. So I've got a lock button. So on my computer, I can hit these two buttons. I layer that button or layer that key, and it locks the computer. I don't want to do it because I don't know what it's going to do to the stream, but it locks the computer. Which is really handy for me because I'm one of those people who locks a computer when they walk away from it. It's very nice that Apple finally decided, after years and years and years, to make the Touch ID button, when you click it, it locks the damn computer. I mean, we've only had Touch ID on MacBooks and MacBook Pros and stuff like that for 10 years now. But finally, because otherwise, this is just mapped to Command Control Q. Which is how normally you lock it. Or you, like some people have a hot corner or whatever, boom, locks it immediately. On Windows, you would use Windows L, I think, to go to the login prompt, something like that. I lost what I was saying. But on my Cornelius, so some of those extra keys, I actually use them. Or I actually have them mapped. I don't necessarily use them because I still have the lock button here. But I have a dedicated just one tap lock button. And I also just noticed my music is dead. Because I was listening to a finite stream. It died about 20 minutes ago. Anyways. So, that was a lot and not super well organized in terms of thoughts or flow or process. I'm going to rewatch this later, and I'm going to try to turn it into a video or maybe a series of videos about ZMK config repos. Oh, I forgot. I wanted to go into how the GitHub build stuff works. So let's do that. I'll do that in a second. So I want to turn this into like a video or series of videos about how ZMK config repos work. From the very basic, like what we first did was walk through the installation, walk through the install guide, download the shell script, run it, add your thing, flash your firmware, boom, you're done. You've got a stock firmware. You're good to go. Never need to touch any of this ever again. To how do I do a combo? How do I do a layer tap? How do I do a mod tap? How do I do home row mods? So it might be a series of short videos because I might just have like home row mods in ZMK, and it's literally just going through this behaviors hold tap and being like, here, we copy paste this over, but it kind of explaining the underlying mechanism for, this is the behaviors node, this is an HM, this is a label, a node label, and you're referencing it later here, right? And that HM, this is the exact same way that layer tap and mod tap are defined. I mean, literally in ZMK's code, there is somewhere in there a behaviors node with LT and with MT. Guaranteed it's in there somewhere because it's just using this underlying behavior, because they're kind of like, well, what do layer taps and mod taps have in common? They're both hold taps. You hold, it does one thing, and you tap and it does another. So how do we change that? The bindings might be a little different. I don't know, but there's something that looks just like this in there for layer tap and mod tap. So yeah, and go through combos. So there might be a series of videos because I think it could be useful. I think there's demand for it. I think it would be fun and a good exercise for me to go through and try to, one, break a complex subject down into independent parts, or at least like very low numbers of dependencies. Like I could do a series of stuff and it kind of builds on it, and maybe that's useful too. But I could also do like, okay, well, we're going to do a combo, but the first thing you have to do is make sure you have your config repo set up. Once you have your config repo set up, this is how you add a combo, right? But I don't want to make it so like in order to do a combo, you have to know all the stuff about device tree and blah, 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 blah. It's just like that were kind of mentioned offhand in previous videos or something like that. I just want to be like, ZMK config repo, here's how to add a combo, build, Bob's your uncle, you're done. And then maybe there's some like more detailed things. I don't know. Ideas. Let me just look up real quick who sent that comment, because that has spawned so much like, oh, there's so much content I could make about this. So I want to personally thank them, YouTube Studio, because, yeah, latest comments, view more. Roy CV comment said, I really like your videos. They relax me a lot while finishing up my RGB soffle. Do you think that in the near future you can make a video on how to configure the layouts with ZMK firmware? Boom, just did. Of course, this is very unorganized, very stream of consciousness, whatever, but I want to I want to improve that. So this is kind of like like I said, script development. let's cover a bunch of content, and then I'll rewatch this and take notes and be like, oh yeah, that'd be really cool to make a video on that, or you know, a blog post or something like that. So yeah, so thank you, Roy CV, for your comments and for this series of videos I'm probably going to make in the future, in the near future. I don't know exactly what the format's going to be like. There's going to be talking head. There's going to be terminal, browser, that sort of thing. Like it may just be this exact kind of setup. But I really want to solve the, like, how do I show my mouse pointer on screen? Because I gesture at stuff all the time and you just can't see it. And highlighting just isn't. Anyways, okay. So that's some notes for up to this point. Now let's dig in a little more into how the GitHub Actions stuff works. So GitHub Actions, I've said before, and actually, you know what? Let me test out my new BRB thing. I am out of water. I could probably use a banana, but not a frustration banana, just a take of 5. So I am going to get a banana, get some water, and I'll be right back. Okay, I am back. Got some water. Got a whole lot more water, which I didn't do this morning because it was down here and I didn't feel like running downstairs and back upstairs. I was like, I'll just take a break halfway through the stream. I got a banana. Banana for scale. Somehow, one of these days I will learn how cameras work. Okay, so. I don't remember whether I'm convinced or not that opening the banana from the bottom is easier. Because someone said why, and I tried it, and I was like, oh, that is so much easier, and I just tried it again, and I think I did it wrong, because it wasn't. That's fine. So. Do a little work here on this. I'm actually going to, for this part, I think just do it all in the browser. Which I'll need to figure out a better layout for when it's just like, okay, we're just looking at the browser. I don't need the terminal and Finder open. But I don't feel like screwing around right now with OBS enough to get this to do it. I also need to do things like see how this works or see how this looks on a phone screen, because this is a 5K display and I'm showing you at almost full size. So these pixels are tiny. I don't know if anybody can read any of this. In fact, let me just go ahead and shrink this. Because this is actually important that y'all can read this. So, fine. Order, move to top. There we go. You know, I wonder if there is such a thing that's like snap this window to a 4:3 aspect ratio or 16:9 aspect ratio or something. Because like 16:9 is if I had this all full screen. But 4:3 is kind of like, okay, that gives me room for this column on the left so that I can have like ZMK config repo stuffs and then my hand cam, and below that the awesome art from Purse. Yeah. There's probably a tool for that. I wonder, I bet you Moom can do it, and I have Moom, so... Nope, that's not what I wanted. I guess I don't have it installed on this computer. Anyways, so let's look at the GitHub Actions stuff. So one of the awesome things about ZMK is that ZMK will kind of by default like sets up GitHub Actions for you and will build your firmware for you in the cloud. And then you can download the firmware and copy. You don't have to build it locally. You don't have anything. So your primary interface with Git or with ZMK could in fact just be like, I'm going to go into config corn.keymap and I'm going to go, wait, I can edit it from here, right? Yeah, I can click on edit and just be like, blah, 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 and then save, and there you go. Like you can, once you've done that initial setup, which now that I'm thinking about it, might not be a bad idea to have a like web-based tool for this. So maybe I'll work on that at some point, so that you can like build me a QMK config repo. You log in with GitHub or ZMK config repo. Anyways, wherever you are, was it Jerry or Lorenzo? Somebody was like keeping a to-do list for me and PRing it. So open a PR to my repo that says make a config builder interface that will do the shell script bits, so that you can just do. Anyways, so you've got your keymap here. It's all in GitHub, and you go to Actions, and you click on your latest thing, and you're like, boom, give me my firmware, and there's your firmware. It's like, it's that easy. That's one of the really awesome things about ZMK. And it's not that QMK can't do this. It's that, at least as far as I knew, Dakes, congratulations, you are the mod for the day. You get to link to that tool. Anyways, like that you can do this entirely web-based and that, but like how does that actually work? Oh, sorry. So what I was saying is QMK, I don't know if it does that now or if it has support, or somebody has probably done it, I'm sure. But last time I looked, that wasn't a thing that QMK had. Not out of the box, not as nicely integrated as ZMK's implementation of it. And the way this works is it leverages a thing called GitHub Actions. GitHub Actions is to not be an ad for GitHub Actions, but GitHub Actions is effectively a continuous integration tool for repos on GitHub. It allows you to run container-based, which may even be more detailed than I want to get into, but allows you to run commands against your code repo and then take the output of those commands and do stuff with that and build this like pipeline of things and then emit an artifact. And that artifact in this case is your firmware. So as you see here, artifact produced during runtime firmware. Boom, right? And the way you tell GitHub Actions what to do as a developer for GitHub Actions is use this github.github/workflows directory in your repo, and you put a YAML file in here. It doesn't matter what the YAML file is. It might be, I don't know. Maybe it does. It needs to be build.yaml. But this YAML file basically says, like, you know, it gives it some instructions on how to do things. I'm not going to get into too much detail on the exact syntax and stuff like that. If you want to learn how that stuff works, GitHub Actions, there's an entire set of documentation about how to GitHub Actions, get started with Actions, all that stuff. We're going to go through, at the very least, what the basic steps of that ZMK has configured. So these build steps here, because I actually don't know the matrix stuff other than like matrix being that you can, it's a build matrix, so you can run this on, say, multiple different environments. So you want to build it on Mac and PC, or you want to build it on Linux or Linux ARM and Linux x86 or whatever is available. You can do all those things. Sweet. Okay, and thank you for being a moderator. You're no longer a moderator. ZMK config builder.netlify.app. Sign in with GitHub. This is risky. Oh, it's Joel, though. It's fine. I trust Joel enough. I trust Joel enough that he's probably not gonna hack my shit. Plus, probably doesn't get enough thing. ZMK auto config test. Let's do private repo. Ooh. This is nice. Oh, and you can add more. Okay. I am definitely going to play around with this tool more. Because, like, the fact that I can go add another keyboard. No, Linux Fish. That's not true, because S'mores was a mod yesterday, and S'mores did not go mad with power. In fact, the mad with power thing the previous time was me getting mad with power. I silenced someone and then made them a mod, because that makes sense that you would do that. Anyways, I'll play with this config builder repo later, or config builder thing later. This could be one of the missing pieces of ZMK workflows that I've been looking for, and may in fact make the video based around the ZMK config builder instead of running the tool. But we'll see. I'll talk to Pete about, because I want this to kind of be official-ish documentation, like, or at least like up to Pete's specs or standards for quality. That I'm not like giving people just horribly bad information. Anyways, so the way the actual build runs or works is runs on Ubuntu latest. That's basically just saying like what image it's running on, or something. I don't know. We'll ignore that step too. So the container it's saying to use. This is like if you're not familiar at all with containers, if you've heard of Docker or Kubernetes, this is that. It's basically a container. If you want to think about it, it's a fancy build environment. It's a fancy, I want to say a fancy tarball that you can execute, but that might even be too much. I don't know. I see it as executable tarballs, whatever. But it's basically saying like, hey, I'm going to build this image that has the tools that I want in it. And it's a little mini Linux environment that I can run stuff inside of without having to like put a CD into a machine and install Linux on it and then apt-get install some packages or whatever. Like, it's already built and it's a standardized thing that like, if you build it with this container, then I build it with this container, we're going to get the same thing. Yeah, emoji picking on YouTube is bad. The emoji stuff is one thing that draws me toward Twitch, but at the same time, I don't understand the like secondary emoji things, like better Twitch TV and stuff like that. Like, why doesn't Twitch buy one of those things and integrate it? Why do those things replicate some of the limitations? Like, I don't know. I don't watch Twitch, and also I don't watch Twitch in an environment that has those things, because I watch Twitch on my phone or on my iPad, and sometimes I will stream it to my TV, right? I don't watch it in a browser, so anyways. But I also don't watch Twitch very much, so I'm not super worried about it. Anyways, so the container that executes on is the kind of the build environment that it's executing within. And in this case, ZMK publishes a container that has the tools and everything that you need to run what the rest of this stuff does, right? So you've got here next the steps. So prepare variables, what this is doing is it's just setting a bunch of variables in the thing. I don't really know. I'm not gonna dig too much into it, but prepare variables. Check out. So this actually goes and checks out the code. So if we look at GitHub Actions documentation, this uses Actions checkout v2 is GitHub Actions Actions checkout v2. So this is actually a canned action. So this action checks out your repository on your GitHub workspace so your workflow can access it. Pretty straightforward. It's its own container that starts up and just runs git clone, basically, or git checkout, or whatever it needs to do, and puts it in a place that then gets put into your other container, your like broader container, into that gets passed to your other build steps. Let's see. Okay, so checkout and then cache. So this cache thing is where, so let's see, GitHub Actions, cache v2. So cache will take cache dependencies and build outputs, and so it there are some directories that it does. I don't know exactly how this works, but this is the step that it's running, the action that it's running, and it basically will very much speed up future runs of this build. Well, I think the thing is that those on-stream or those Better Twitch TV and stuff are like... So if I write... Because the way Twitch emotes work, if I just do PogChamp, boom. What that does is on Twitch, it changes that to the PogChamp face. But if I do like Kitchen Pog, if I have declared or defined an emote Kitchen Pog in my channel, it replaces that with that channel. Or like if you're posting on someone else's channel, you can use emotes you have access to or something. But the extensions use that exact same technique for string replacing it in there. So if I do like BTTV Kitchen Pog, and I'm I realize the stream is delayed, and so I'm typing in a chat, and you're like, the hell is he talking about? And then see it anyways. If I do BTTV Kitchen Pog, regular Twitch users just see BTTV Kitchen Pog, whereas anybody with BTTV installed sees the whatever BTTV Kitchen Pog is. But even that has limits, like, oh, you can only have certain numbers based on your follower counts, or you know, I don't get it. I just don't understand the I don't get Twitch. I don't get the ecosystem. I don't get the I haven't, and it's not that it's hard to understand. I just haven't ever been a part of that. Like Twitch has a long history at this point, years and years of usage and culture, and I'm a complete outsider to that. I don't know the tools. I don't know why you would use them, how you use them, what the pros and cons are, that sort of stuff, and I just don't care. And so, like, for me to like stream on Twitch, I would feel very awkward because I'd be seeing things that don't make any sense to me, like people using emotes that I'm like, I don't know what that is supposed to mean. It's like you're saying a word, like I'm gonna say flibble. Oh, that's pretty flibble, man. And I'll be like, the hell does that even mean? Like when and this is my gray hair, neck beard, old man, get off my lawn talking. People, for a while, people were saying based, and I'm like, what does that mean? Right? And it's not that I'm saying don't use that word. I just don't understand what you're saying. Right? Like, it's just a shift in culture over time, and that's awesome. I love it. I just have gotten lost at this point. Anyways. That's why I'm not on Twitch, because I just don't know enough about it. Even though I recognize that in a lot of ways it's way better than YouTube streaming, I just don't get it. And I don't watch enough streaming on YouTube either to really know how YouTube's chat works. Anyways. I build keyboards and write code and stuff. Yeah. Discord now. If I could just embed Discord chat into my stream chat, I would get rid of... I stream on anything. It's like, okay, great. The platform is just the place that's transporting the video from my OBS to your display, and then we have a Discord channel that we're talking about it in. And you can use Discord for that. Kind of. But then you lose out on all the discoverability of Twitch and YouTube and all that stuff. So I don't know. But I hope at some point that Discord comes up with something to compete with that. And I know I probably could have gone and worked there and maybe be working on doing that very thing and not. But I really, instead of working for Discord, I would rather hike the Appalachian Trail next year. So that's what I'm going to do. Anyways, yes, kids these days and their made up internet words. And to try to put a bow on this this tangent, this segue, because internet, understanding the new rules of language. This is a fascinating book. I haven't even finished reading it. It's really, really mind-blowing, but it goes into a lot of the culture and a lot of the language and a lot of like one of the things that it mentions is why you see certain numbers for like Chinese website domains. It's because the way they sound, or because the way I'm not even doing it. I can't even explain it. It goes into why so many things because internet. It's fascinating. Go read this book. Highly recommend it. Just search for because internet. You don't have to get it on Amazon. It just was the first result. So anyways, and it's $5 on the Kindle. And if you can't afford it and want to read it, hit me up in Discord. I'll buy it for you. $5. Yeah. Anyways. So, actions. So, cache west modules. So this will do something. It caches things. It says cache name, cache Zephyr modules. So basically you can specify on the GitHub side of things, like what cache top level kind of directory you want to put all these things in. And then it says with path modules Zephyr tools. So basically it'll just copy all those files to this cache called cache Zephyr modules inside of your cache namespace. The actual implementation of this is probably either a big Redis style key value store that it shoves all this stuff in, maybe even Couchbase or something like that, or it could just be an S3 bucket that has expiration. I don't know. It just basically just dumps all these files onto somewhere that it can then fetch back later. And so the cache thing is like, if it's there, grab it, and if it's not there, put it there. So restore keys, you've got all this stuff, whatever. Again, dig into the docs for the actual Actions Cache v2 for more information about how this works. But this is how subsequent builds of ZMK, of your config repo, are, as they're faster than the first one. West init, what that does, West is Zephyr's build system. If you're familiar with building software on Linux, it's Make, it's Rake, it's Maven, it's whatever. In fact, it's much more than Make and much more than Rake, because it also handles package dependencies. So if you look at the build.yaml, no, config west.yaml. So if you look at west.yaml here, it says, okay, so the West manifest says remotes ZMK firmware, and then projects name ZMK, remote ZMK firmware, import app west.yaml. So what this does is it basically goes and clones the ZMK firmware into ZMK, and then inside of there it chains into so this import app west.yaml chains into ZMK's west.yaml file, which has all of ZMK's dependencies, pulls all those in, which probably then have their own west.yamls and pulls in all those dependencies and everything. And it just kind of pulls all the stuff in and makes a big directory full of all the dependencies out of it so that it can build it. If you're So it's kind of like make and a gem file, if you're familiar with Ruby, in one ball, right? It's really, really cool. She reads the audiobook. I should get the audiobook. I don't really listen to audiobooks, but I feel like that's an audiobook that would be good, or that's a book that would be good to hear in someone else's voice. Because I hear it in my own voice when I'm reading it, but in someone else's voice, like, that's different context. So we go back to build.yaml. Steps, cache, west init. So west init, basically what that does is just says like, hey, this is a west repo, put stuff here. I don't really know exactly. West update then pulls down all of the dependencies, and if there are differences in dependencies, so maybe you have maybe ZMK updated, but your cached version is different. It will actually update it and update all the dependent dependencies and all the stuff. Oh no, I'm very prone to being derailed, so don't worry. If I wanted this to be like proper video, I will make it without distractions and edit it. But since this is stream, it's just like I would rather interact. Mostly what I want to do is interact with y'all. Like, unless we're completely off topic, we're talking about trains or something like that. But even that I would talk about. Anyways, so West Zephyr export, I'm not entirely sure what that does, but it does something where it's like, it kind of declares your config directory as a Zephyr module, I think, and puts some stock like cmakelist.txt files. Cmakelist.txt is a kind of like a make targets declaration, saying like these files need to be built, whatever. And then West build. So this is the meat of this file here. West build -s ZMK/app, and what's that's saying is like, this is your source directory. ZMK/app is the application that you're building. So West is built in this like, or Zephyr is built in this like idea of you build an application and it incorporates all of it pulls in all the operating system underneath it. So then -b is your matrix.board. So it's your board that you're building for. And in this case, it's a nice nano, and the matrix is coming from up here. This is probably some way to make it so it can support multiple things at the same time. Yes, in fact it is. This is a way, so this is different than what it used to be. This is a single, okay, this is a single, I'm really excited about this. A single actions file that builds multiple keyboards. And it does it based on this build.yaml. Include board, nice nano, shield. So you could add, yes, okay, this is great. Because the way I've done this in the past is manual. You're copying all these things manually. So I'm gonna definitely be rebuilding my config repo at some point. Sorry. And see, I'm learning. This is part of what's fun about this, about streaming, is that I'm trying to teach, or I'm trying to show people what to do, or just like have fun, but I'm learning about all this stuff at the same time. Because like trying to explain it to you means I have to look at it, understand it, and then regurgitate it in some sort of fashion, right? But I'm looking at this, and this is something, I haven't looked at this file in a long time. I haven't looked at the obviously modernized version of this file ever, because this is very different than what I'm used to, and I'm very excited by it. So anyways, so what this matrix here is going to do is it looks at the build.yaml file at the top level. So it matrix equals blah, 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 and it YAML to JSON. So it's this command here is taking that matrix or that build.yaml file and converting it into something that GitHub Actions matrix build process understands. And a matrix build is, in this case, you're specifying, here are the different boards and shields I want to build. Here's like a list, but they call it a matrix because they say you want to build for, good example, say you want to build for ARM and x86, but you want to build the 32-bit and 64-bit versions of both. That's a matrix. So you've got a 2x2 matrix. You've got x86 and ARM. You've got 32-bit and 64-bit. And so you turn that into a matrix, and it'll build it 4 times, one for each combination of those 2 columns. But matrices are not limited to 2 dimensions, and they're not limited to 2x2. So you can declare a matrix as JSON, and it'll the GitHub Actions thing will go through and parse all that and be like, okay, here's the like potentially thousands of build configurations I need to build, and that's it. It's not even just like architectures. It could be build configurations. Maybe you want one with debugging enabled, one without debugging enabled, maybe one with certain features enabled. You want a lighter weight version of it, so you have one that has, an example is, I have many Korn keyboards, and in QMK it'd be nice to be able to say I want a Korn keyboard with all the bells and whistles, so RGBs, OLEDs, all that stuff, and I want Korns without it. That's a simple matrix. That's a simple build parameter that I could do. It's like, hey, I want to build all these Korns, or I want to build firmware for Korn with the RGB and OLEDs enabled, and without RGB OLEDs enabled. Maybe I have some that have like RGBs but no OLEDs, which I don't think I do. And maybe I have some with OLEDs without RGBs, which I definitely don't. So you can also exclude some of those matrix options generally, or just build all 4 of them and only use the 2 that you need. Anyways, matrix, cool stuff. Very common feature of a build system is to have the ability to do matrix builds, where you have a template build that runs on a matrixed set of build configurations. And in this case, the matrix is board and shield combinations. Sound good? Okay. So that's what these prepare variables thing are, is it's saying, okay, name extra CMake args. And if we look at extra CMake args, there's like what shield you're building. Artifact name is what the actual name of the artifact should be. So in we get firmware, or what is it? Firmware. So if we look in the, I hit it. Let's move this to the top for a second. So if we look at this, we've got Korn write nice nano ZMK UF2. So this is a combination. This is coming from that artifact name, and it's saying shield.board -ZMK. So we've got Korn write nice nano ZMK UF2, right? That's exactly where that's coming from. So these variables are just setting the variables that are used later in this build configuration for building multiple keyboards in the same build file. This is so super cool. I'm glad I'm doing this because, like I said, I didn't know that this had been done. And I'm excited about it because this makes it much easier to build multiple keyboards in the same repo. Because like I said before, and I can even go into my build.yaml or build.yamls in my ZMK config and show you like the nasty stuff I do to make it work. Anyways, so West build, so it says, so let's go back here. This is the meat of it. It's saying West build -s ZMK app. So it's saying build the ZMK/app directory. We want to use this board. We want to use this ZMK config directory, and this config this is so GitHub Workspace. That's where this repo is checked out to inside the container. But the /config directory within that. And this is just saying, this is just a define telling ZMK, telling the build system, setting a variable in there that then the build system uses. And ZMK uses that to find to kind of enumerate locations that should look for overlays, for keymaps, for all that sort of stuff. And this is all deep into the ZMK build stuff. How this is actually used. But then steps.variables.outputs extra CMake args. So in this case, if we go back up here, extra CMake args, it says what shield you're building, right? And the shield in this case, so the reason this is here is because Zaphod doesn't have a shield. Zaphod is a board. Because a shield and board in one is just a board, at least in ZMK terms. I think in Zephyr they would still prefer you to have board. But the problem is, what would your board be in this case? Because it's not like it's a pluggable thing, so it's just a board, right? But, and the Cornish Zen is also just a board, right? But this is a board, the nice nano board, and a shield. So in order to support both types in the matrix, it just says if there's a shield or not. Because if there's a shield, you need to define the shield, and that's actually Zephyr has the concept of boards and shields, so that actually tells Zephyr which shield to build, and ZMK just kind of integrates with that for how to kind of select how to map things. I'm not stating that well how that works, but just suffice to say that that's going to underneath to Zephyr, the shield thing, right? So steps.variables outputs equals extra CMake args, and then matrix.cmakes args. So variables here, set output, so it doesn't say here anything about CMake args, so that's probably that you can put in the actual yes, so that's so you can specify in the build.yaml file, that top level one, this build.yaml file, you can put CMake args in here as well. So if you wanted to have specific CMake args, not that probably anything really uses that, but it's a extensibility kind of attachment point, or it's a hook, whatever you want to call it. Anyways, go back to the build here. So that actually builds the firmware. And so since there's a left and a right, if we look, I should just, let me open up the, oh, wow. This went to sleep. So I have to wait for the Zen to wake up. Oops, okay. Let's just close this. So if we go back to the top level build.yaml, we see include board, corn left, corn right. Now there's probably a way they could make it so you could just say include, shield is corn, and it knows internally in the build system that this is a split. It's so much easier just to say, well, you just build both halves, just whatever, right? Then nothing needs to know that a corn is two halves. You just say, build the corn left, build the corn right. Because in the background, that shield is getting passed as d shield equals corn left, corn right. And that has always been that way. It's just been two separate build steps in the same build file, right? So this is doing the same thing, except it's two separate matrices, or two separate entire like sections of the matrix. Yeah, anyways. So that outputs the output of this file, or of this, is a ZMK.uf2 file, which will get worked later. So you can see right here. But remember how I was saying that you sometimes get those device tree errors, and you're like, what? This step here just cats that file out. So, and this is if always. So that means that if the build fails, no matter what happens, this step runs. Because one of the most important debugging tools you have here is what the hell is even in my device tree. Because oftentimes the build fails because of your device tree file. So this gives you that. And it says, if the build file, then cat it out. Or if there's a zephyr.dts file, build that and copy it out. Right? Because like if this, sometimes Zephyr can fail, or this is basically like a fallback, because this zephyr.tts file gets concatenated into this bigger pre.temp file. This is the whole thing, and this is like one of the interstitial build steps. So maybe if that's failing, it's because the zephyr.tts file. I'm not really sure why this is here, but that's my guess, is that this is like an interstitial or an intermediary build output that or intermediary build step that gets removed later, but could fail earlier on. I don't know. So this similarly shows you the kconfig, because if you screw up your kconfig, then that can also cause problems. So when I say kconfig, I mean the in the config directory, this is your kconfig file, right? So a lot of this stuff comes from the Linux kernel, these tools, in terms of like device tree and the kconfig. Kconfig is kernel config, so you can actually, if you've ever built a Linux kernel by hand, and I haven't done that in 15 years, but if you've ever done make menu config in your Linux kernel source directory, it's the same thing. You can do west menu config. It's not exactly that easy, but you can do west menu config, and it'll pull up a menu-based configuration interface and spit out a config file. Well, or you can just pass it some config options. Same thing. It's the exact same tooling and everything that works in the background. So that this is probably just saying, like, here's the compiled .config file without comments and stuff like that, just in case there's an error in your kconfig file, right? So then this rename artifacts thing, what this is doing is the output of the build command is the zmk.uf2 file. So it's going to say, well, that's, we can't just make, if we're doing a build matrix here, we've got corn left, corn right, we've got a zaphod, we've got a whatever. You can't just have zmk.uf2 that has all of those in there. They have to be individual. So it renames those. The nice thing is that the output is just a single file, and it's a constant name, so it can just rename that. The other way you might do it is to specify an output file in your build step. I don't know if that's possible, but this way works just as well, because specifying an output file in your build step probably just says this inside. So it's just renaming that into the directory, or renaming that, or copying that from the build directory into the artifacts directory. Then The artifacts directory in GitHub Actions is a little bit special, or isn't special unless you use this archive upload artifact action, right? Path build artifacts, right? So this is saying zip everything in build artifacts up, call it firmware, and there you go. That's your output of your artifacts. So, wow, this is so much nicer than it used to be. Let me just, for edification here. So the way this used to work is you had, as you can see, I have multiple of these files. These are all identical except for a few things. So let me actually just show you. Let's get back to blah. Well, I was going to show you a diff between these files, but my terminal is, yeah. Anyways, so like the way this used to work is it do a lot of the same things, but it had this hard-coded build step here. So it's like, okay, West build, ZMK, nice nano, corn left, right? And then here's the corn right. But it also like corn DTS file, corn left kconfig file, rename ZMK UF2, and then it does the exact same thing for corn right with different things, and then does that. So the new method just takes all of these, this, and makes that into a matrix that you can specify as a build.yaml file at the top of the repo, and this one unmodified, let's see, where's that at? This one unmodified build file, build.yaml file, will build any number of keyboards you want. And I think that's awesome. I think that's so awesome, because it used to not be that way. Oh, I know where you might use CMake or use extra CMake args. So the Reviung and the Reviung LP, and possibly even the Reviung Chalk V2, have different pin assignments for the matrix. But they're both variants of the Reviung. So in my keymap directory, or my keymap, and this is actually why I haven't used the Chalk V2 Reviung at all, because I didn't get this working, and I just moved past it. So I've got this Rev 41 LP, and it is building a Reviung 41. Nice nano. But then there's the Reviung 41 LP, which builds Reviung 41. Oh, wait. Maybe that's the problem. So there's a... Oh, wait, that's right. Okay. So it builds a Reviung 41, but in the Reviung 41 LP, there's DTC overlay files. So there's a Reviung 41 LP overlay. So what I was trying to do was, because you specify the overlay file, which, and I'm really getting into weeds now, specify the overlay file, because Reviung 41 is a proper upstream ZMK board, or a shield, I should say. The Reviung 41 LP is not, or wasn't when I built this originally. But they're basically the same thing. So you just need to specify the different pinouts, and that's what the Reviung 41 LP overlay does, is it says, you know, here's the keymap transform, and here's the matrix assignment, right? This is just different between the Reviung 41 and the Reviung 41 LP. So that is a place where you would use that extra CMake args in the build here, is to say, here's your DTC overlay file. So I may actually use this when I consolidate my config repos, which I was thinking about like starting on today, but we're already a little over 3 hours in, and I gotta hold something for later, you know? So I think I'll probably do that tomorrow. And then maybe get my Reviung Chalk V2 Reviung working finally. Because it's just sitting in a box. Like, it's all built and works, I think. I just have never used it because, yeah. So, anyways, this was a lot of fun. I learned a lot going through this. I have many ideas now. I really need to rewatch this. I'll probably watch it on like 2x and maybe with the sound off so I don't have to hear my own voice. But I really want to rewatch this and take notes and come up with a set. I don't want to say a series because the series implies that you have to watch A to B to C. I want to make a set of videos that covers a lot of what we covered today in more consumable format. Yes, there is an LP version and it will be available from MK Ultra very soon, I think. It was designed by shit, I can't even remember at this point. But I do take a little bit of credit for some of what's in there because there's a power switch and battery solder pads, and you're welcome. Because I wanted to build it as wireless, and I was like, man, it'd be really nice to have like a place to solder the battery to that isn't like just bodged in place, and then a power switch so I can cut the battery off. Because like this, if you look at the back of this, there's 2 wires that go through this that get connected to this little power switch, which is just plugged in. It's not soldered to anything. This power switch is only held in by the solder joints of the wires that are on the other side of it that aren't soldered to anything but the pins. Like, and there's a bunch of hot snot back here. Like, if you look at my blog post for it, there's pictures. I built another one for somebody else, almost identical to this, the same version of the PCB and stuff like that. Much cleaner, but it's still the same kind of like, it's just bodged all together. Non-linear sequencer related videos. Yeah, a set. It's just a set. There's no... There may be some graph within it, because there will probably be a do your ZMK config repo, and then some things that, well, this video assumes that you've already done the ZMK config repo. So if you've already done that, great. If you haven't, go watch this other video. But that's about as deep as that dependency tree is going to get, more than likely. Except for like the later videos that might, I say later videos, the more in-depth videos might the stuff that like digs into the build, stuff that digs into how device tree works, that sort of stuff, like that may kind of be not inherently dependent, I don't want to say, but kind of like soft dependent on you having seen the rest of them, because I'm going to reference stuff from the other videos, but it won't be like, if you're watching this, you probably already understand that or can figure it out on your own, because like nobody's going to dig into device tree anyways. Yes, so tomorrow I will do my ZMK config repo consolidation and modernization. I am super, again, I just want to say thank you again to Dan CV. Who was that? I want to say thank you again to the commenter who prompted this video or the stream today, and the set of videos that will hopefully come from this, because this has been fun, like just digging into this stuff and learning how it's changed in the year since I started using ZMK, and how it's better than it was before. I don't know. It's just been really fun stream for me, right? I love it when streams are fun for me, because then I'm not worried about if they're fun for y'all, because I'm like, I'm having a great time. This is awesome. If I'm not having fun, I'm assuming nobody else is either. So anyways, I'm going to call it for today. Tomorrow we will do consolidation of ZMK config repo. Hopefully get all of my... I'll dig out all my ZMK boards. If you were here yesterday and heard about the light fiasco, I say fiasco. One of my lights, the power switch broke. I fixed it. I didn't fix the power switch because it's beyond repair, at least beyond what I felt like trying to screw around with. So I literally just took it's a single pole double throw switch. I took the pole and I wired it to the one side that it needed to be and soldered it. And now it is just an always on light, but that's fine because I have it on a switched outlet, so I can switch it off using the outlet. Works perfect. And that is why I have lighting coming from above. It's not great for face lighting. I need to figure out something for like how to light my face. I might just move this light closer, but it needs to be lower down too. I don't know. We'll see. Stuff to play around with. I might reach out to some of you for like, hey, can you like watch some of this video and tell me if it's horrible? Like, oh man, your audio is terrible. You really need a better mic. Or, oh, the lighting is bad. Or, oh, that hand display is useless. Or there's too much shit on your desk. Or whatever. Like, I'd love to have that feedback because... Wrong bite. Because when it's just streaming, I feel like it's much less formal. I'm just here screwing around, hanging out in chat, and like talking to people. But when it's like video, I need it to be, or I feel like it should be more produced, right? It should be scripted, if for no other reason, because I can't stay on a track for the life of me. So if I have a script, at least I have something that I can follow along with, and when I get lost or I find myself going off script, I can go cut and then back up, reshoot a segment, something like that. So I might reach out to some people. I don't have a Patreon, so I'm not going to be like, oh, my Patreon subscribers get to see the uncut. No. That not yet anyways. We'll see later at some point, but I doubt I'll get to that. But anyways, I'm rambling. I'm caffeinated. But at the same time, I'm also kind of tired because streaming while fun is can be exhausting. Because it's like, I'm just sitting here talking for 3.5 hours to a camera, to a bunch of people I can't see. Which is fun, but yeah. So tomorrow, ZMK config repo consolidation and modernization. And I'll dig out all of my nice nano, or all of my ZMK keyboards, including the banana, and get those so that I can like flash them all on stream and be like, okay, great. Now all of my ZMK keyboards are running the proper kitchen 34 key layout keymap, modern versions of ZMK, and they all work. And if one doesn't work for whatever reason, figure out why, right? Or at least put it in the queue of like, this one doesn't work because the pin mapping is wrong or something like that. I don't know. But we'll see. Anyways, thank you. It's been a good stream. A lot of fun. And let me know if you have any feedback on like the layout, especially for like if I'm sharing screen, because I don't want to just share the whole screen. One, because it's way too many pixels. You would not be able to read anything unless I just like in each application just was like, okay, well, I'm gonna make the text size be, you know, this big, right? Because then when it's full screen scaled down into a 1080p, you might actually be able to read it, because that's not very useful for me. But at the same time, like, maybe that I need to do that. But also because, like, then you would see my OBS, which it's not like it's trade secret or anything, but like I need to be able to see OBS as a confidence display, to know like what's on there, to be able to interact with it. And right now I only have this hooked up with one monitor. I have another monitor I could hook up, but I don't have anywhere to put it unless I like somehow stack it vertically, which I don't have any way to do. So I can't do that right now. So that's why I can't just full screen share the whole screen, as much as it would be, I think, very much easier for me to manage. I would need a second display to put OBS, to put the YouTube chat on. And like I have another Safari window that has a YouTube chat, it has my Gmail, it has my the music that's playing in the background. I might do it a little mini behind the scenes video at some point. Not that there's huge amounts of behind the scenes, but just because it kind of could be fun to see. Like, I like seeing what other people have for their setups. Yeah, it's just hard for me to share full screen everything. Because like this, blow it up really big, that's actually fine. Because then what I do, which I can't do because it'll screw up, like, OBS captures whatever it is, and anyways, like, I could just resize the window so I have that much more text. And then it's fine that it's like font size 72. But yeah, the biggest problem is that I just have one screen right now. So, anyways, and I don't think I want to do where I have like, because I can use my iPad as a second display trivially. It's built into Mac and iPad. Like, I just second display, doesn't even need to be plugged in, does it wireless. I've done it before, works pretty great. I don't know if I really want to have iPad as second display with OBS and stuff on it, but we'll see. Anyways, I'm gonna call it. Finally, stop rambling. Have a great day. Have a great weekend. If you're not coming back tomorrow, that's fine. If you're coming back tomorrow, awesome. If you have ideas, or if you're like, hey man, you do a lot about ZMK, but you don't do anything about QMK, I'm happy to talk about my QMK setup. I haven't dug that much into QMK because the clean room thing, I have kind of put my support behind ZMK at this point. So if I'm going to dig into code, I want to not do that in QMK as much as possible, because I don't want that to possibly contaminate the clean room. So I haven't done that, but I can at least talk about the little things that I've done in QMK, because obviously I have QMK boards. Anyways, calling it. Have a good day. Have a good weekend. Bye. I'm going to stop rambling now. See you. Thanks, everyone.